Hi everyone, my name is Jasmina Lazendic-Galloway and I'm a research fellow at TU Innovation Space in Eindhoven University of Technology in the Netherlands, and also senior research fellow at School of Physics and Astronomy at Monash University in Australia. And today I'll talk to you about how I modified lab reports in one of my physics courses. So the context of this talk is set in PACE studios at Monash University, which are built in 2014, and they stand for Physics and Astronomy Collaborative Learning Environment. They are modeled on the scale-up studios from North Carolina University. And the biggest change that they brought to physics teaching is that instead of having many labs run by teaching associates with only 20 students in each lab, we were able to place 100 or 110 students in labs run by an instructor and with help with TAs. And therefore, the instructor could get better sense of how students are thinking. You can walk around and listen to them talking and tinkering and asking questions. So it allows for much more interaction than in the past when we had these separate labs. So about 200 students enroll it every year, and we just teach internal mechanics, electromagnetism, which used to be waves and optics before, and then quantum mechanics. So typically we would have lectures in which there's information transfer, then tutorials in which we give problem sets to students to work on together with the support of TAs, and then also labs in which we try to teach students about experimental side of physics, or what our students tend to say, just uncertainties. So of course, work in lectures and tutorials is assessed via mid-semester tests and exam, and labs are assessed via lab reports. And lab reports tend to be quite prescriptive. We used to want a certain structure where students explain the experiment, how they're taking the data, what the data is and what the data says, and then calculate uncertainties and tell us what that means. So although we are assessing different skills, the reason used for both lab reports or tests or exams should be the same. But of course, the students are often not able to see that. So of course, we have an issue here about novice versus expert problem-solving methodology. And we as experts see things a certain way. We can evaluate our judgment. We can see connection between the concepts. For students, that's harder. They see concepts as isolated facts. They often don't have a strategy in place to solve the problems. They read first sentence and then grab first equation that they think is relevant. So I really want to address this problem and help students grow from novice to experts. With PACE, we were able to set up sort of lectorials where we had a bit more interaction with students through clickers and sort of having more discussions in class. And then we would have labs one week, and other weeks we'll have tutorials. But with labs, they would produce reports. I was inspired by use of dual feedback, which I saw from our radiology department at Monash, and they created something called Integration of Science and Practice, or ViCEPHEC, through which they wanted to model decision-making process of professionals in radiology. So I wanted to implement something similar in physics. As I mentioned, in the past, reports were quite prescriptive because they were meant to report on the outcome of an experiment. But what we often see is the students generally describe results of the experiment quite superficially. So I wanted to see more thinking in their reports so that TAs can provide more of the feedback on the thinking process rather than just on the result, if this is correct or not. So students will submit their report, which is digital. We have Moodle as our learning management system, so they would submit digital report. And then questions are tagged. What that means is that I wanted for students to understand that the same skill is used regardless whether we work on mechanics or electromagnetism. It's the same skill. It's the same type of thinking they're using, although the content is different. So by tagging questions according to the skill, I was hoping that they will start to see the pattern of their thinking for different type of questions. And then after they submit their initial report, an expert report will open. So that's usually about 2 days after the lab has done. An expert report will open, and the students will be able straight away to get a feedback and compare how they're done and how us as lecturers would have answered this. Then they will have to answer reflection questions. And again, the questions will be tagged to the same skill that the original report had, but they can't be superficial. So it starts simply by saying, how does your answer compare to the experts? But then does your answer clearly describe the detail of the method, including what to measure and how to then determine the moment of inertia from these quantities? Have you clearly identified variables measured and used and any assumptions made? So they have to really deeply look at what they've done and compare straight away. And of course, in that process, they're learning already, right? So this is intrinsic feedback. They have to figure out themselves what they've done wrong. And then, of course, they submit that, and then TA can mark both of them. In Moodle, I was able to use marking by learning outcomes. So I could set up learning outcomes per question, per each question. And then instead of grades, I just used learning for mastery. So it starts with not demonstrated. And of course, then the next level is developing. These are developing skills, and then demonstrated skills, and then, of course, mastered. And students cannot escape feedback then, because when they look at the gradebook in Moodle, they actually see this level attained per skill. And Moodle converts that into some kind of mark. But in the past, they usually just focus on a mark. If they see, 12 out of 18, they will come and say, why did I lose the mark? They wouldn't even look at it themselves and try and figure out, through the feedback TF provided. But this way, it's there. They can't escape it. So they have a bit more responsibility, a little bit more ownership of their learning. And they also are able to compare how they done in respect to the cohort, which we know it's important. Rubric is relatively simple because it needs to address each of these questions. And so it's purposely simple not to be too formulaic. So the students, again, don't just follow a certain formula per type of question. And again, something that just gives them enough information of what's expected, but not prescribe how a solution should look. So this provides the dual feedback. There's intrinsic feedback that they get first, which is when they compare the initial work to the work of experts. And then, of course, there's external feedback that they get from TAs after marking. So did it work in the end? I quoted the answers to the open-ended question in the end of the year survey from 2016, when we still ran the unit in the old way, and then 2017 and 18, when we introduced the reflection reports. So in this table, I list the top 5 themes identified through inductive coding of open-ended answers to the question, which aspect of the unit did you find most effective? So in each 3 years, we had similar number of students, around 200. And as you can see, the rate of response has been increasing, maybe because our students are learning the value of feedback, and we're encouraging them always to give feedback to us. So lab has been always identified as one of the important aspects of learning in the courses. And what you can notice is that from the year we started introducing these reflective lab reports, they started to be mentioned as the effective way of learning. Although we had reports before, they were never mentioned before as a really useful and effective way to learn physics. But in their own words, the students said, the feedback method is very impressive because we can find out our weaknesses and strengths in this unit. And this is exactly what I wanted. I wanted them to understand, rather than just having a shock of their life when they have mid-semester test or exam and learn too late what they don't know. I wanted them to get a better feedback weekly of which concepts they are understanding well and which concepts they have to work on more. Another student said, I thought it was great that a lot of our in-class assessment had a focus on demonstrating that we were in the process of learning the material. And this is what we want from our learners. But we really just want them to focus on the growth of their knowledge and skills. The answers didn't necessarily have to be correct as long as we made a good effort and recognized our mistakes. And that's brilliant. That's what we want from our students. And that's often what they shy from, just because it's too much work. We'd get a decent grade. This took the pressure off the assessment a little, thus letting us have more time to focus on learning the material. This sentence is just brilliant. I love it so much because it's basically capturing exactly what I wanted students to get out of this type of assessment. And of course, we have a smaller number of students who are not very enthusiastic about these reports. And one of them said, cancel reflection reports. We are scientists, not writers. But of course, as we know, writing is important for development of learning. So I hope you find this useful and feel free to get in touch with any questions. Thank you.